Hello, everyone, and we'll now officially start our biweekly AHA seminar series. We have a wonderful speaker here today. Krzysztof Gajos is a professor at the School of Engineering and Applied Sciences at Harvard, and where he works at the intersection of AI and interactive systems, basically working on intelligent interactive systems. He studies principles and applications of these systems and invents new tools and methods for behavioral research at scale, as well as designing for equity and social justice with intelligent systems. He is a frequent contributor to the CHI conference, the ACM Human-Computer Interaction Conference, also the ACM Intelligent User Interfaces Conference, which he actually ran one year and where he received the most impactful paper as well another year for his work on automating or automatically generating personalized user interfaces. He has won numerous Best Paper awards, and today we will hear about his work in AI systems that assist people with decision making and what the impact is on people of having AI helping you, assisting you with decision making. Very important work in the context of understanding whether AI leads to human flourishing and better human performance and learning. So, Krzysztof, I will let you take the lead now, and then we'll have a Q&A after. People can feel free to put questions in the Q&A. I'll also look at the chat and we'll address those after the talk. Thank you.
Thank you, Patty, and thank you for inviting me here. When I planned this talk, I did not quite realize that the time limit was 25 minutes. So since I designed it first, I had to cut quite a lot of content, shorten some other things, but I still think it will be an informative conversation. So kind of to spoil the suspense, the thought that I had at the back of my mind when I was writing this talk was the fact that our community faces a lot of critique about what we do and why and the impact that we're having on the world. And I realized that actually the critique that I received across many years of my career, once I became comfortable with being critiqued by others, I realized that it often pointed to new, interesting, and exciting directions for my research that perhaps I would not have spotted without that critique. So I will show you several examples of where such critique made me rethink what are the objectives of my work and how that led to a new design and technical approaches. So right now, I am a professor of computer science at Harvard, and I lead the Intelligent Interactive Systems group, where I work with a lot of really wonderful people. And I am also part of our Center for Human-Driven AI Research and Methods, and our acronym is CHARM. So I have been working at this intersection of AI and interaction essentially since the very beginning of my research career, which started at the MIT AI Lab in 1997. And one of my very earliest influences was this article, and generally the broader debate that was happening at that time between the intelligent user interfaces community and the kind of mainstream HCI community. So on the one hand, Patty and several others were making a point that the kinds of things that we wanted to do with computers were becoming more and more complex, and the traditional HCI methods were not being sufficient. So traditional HCI presumes, or the direct manipulation paradigm that Ben championed, presumes that we do everything with our own two hands, that we directly control absolutely everything about the task. It's like being a musician. And Patty, and I'm sorry if I'm putting words in your mouth, argued that we sometimes want to be conductors and not musicians. We want to delegate some of the details of performance to others so that we can control a larger enterprise. Meanwhile, Ben Schneiderman, representing the direct manipulation perspective, says, okay, this is all fine, but all I see from you guys is happy stories, demos, and best case scenarios. But what I really want to see is you seriously focusing on user productivity and doing studies where you look at real people doing real or realistic tasks and show me the numbers. Show me that you really improve people's performance, reduce errors, increase satisfaction. And this is actually challenging when you build intelligent interactive systems, because how do you build a system that is reliably useful, even though the underlying technology under the hood is occasionally wrong? How do you build a system that allows people to form useful mental models of how it behaves if the technology under the hood is inherently incredibly complex? How do you give people a meaningful sense of control of the system they work with if the system delivers the most value, if it's allowed to be proactive, and if it's allowed to be occasionally autonomous? And lastly, traditional HCI focused on building tools. And one very important thing about tools is that fluent users of tools forget that they're using tools. Their entire attention is on the primary task. But with AI, it's often very difficult to do, especially if the AI makes consequential errors. You do have to allocate some of your attention to the tool, to the AI, and not just to the primary task. So building useful, predictable, controllable, intelligent interactive systems is actually a difficult but exciting challenge. So I've worked in the space for a long time. I've built many systems, but I really want to jump to relatively recent past, where we started working on AI-assisted decision-making. That was in 2019. And when we started working in this area, I still had this, Ben inside my head saying, let's study real people doing real things, which was not what people were doing at the time. So we decided to run a fairly realistic study. We recruited 220 clinicians, and we had them read 17 different vignettes about patients with complex cases of depression and assign a treatment to them. This was a very difficult task, deliberately chosen to be so. So only about 36% of the responses that we got from clinicians when they were not assisted by the AI were correct with respect to consensus of experts. The AI was better, though not perfect. And everybody at the time hoped that when you combine human and machine intelligence, you will get something that is that performs better than either of the two alone. But as we now know, this is rarely the case. So the results that we actually got was that clinicians assisted by AI did no better than clinicians without AI support. Many people at the time argued that what we needed to do was to increase people's trust in the AI, but our results suggested that a different mechanism may be at play. So specifically, we disaggregated our data and looked separately at situations when AI was correct and when AI was incorrect. So when AI was incorrect, people supported by incorrect AI performed worse than if they had no AI support. This indicated that there was some level of over-reliance on the AI. People didn't combine their own knowledge with the AI's knowledge. They accepted AI's recommendation when they shouldn't have to. And when we added explanations, different types of explanations, we saw no improvement either in the overall accuracy or in terms of over-reliance. So this made us suspect that what was going on was that when people were given easy answers, they were not engaging cognitively with the task, and perhaps we needed to do something different. So we found a promising concept in the medical cognition literature called cognitive forcing, which is the idea that you disrupt people's heuristic or effortless thinking at a critical moment so that they step into more analytical thinking mode. An example of cognitive forcing is, for example, when you ask a person to make a decision on their own, so they make and record a decision, and then you tell them what the AI's recommendation is and its explanation, and then you ask a person to confront their own decision with AI's recommendation and reconcile any differences. So we ran this study, and just looking at situations when AI provided incorrect suggestions, we saw that this was a task where people over relied a lot without cognitive forcing. But cognitive forcing was able to reduce people's over reliance quite substantially, but it did not eliminate it completely. So, kind of following our inner bend, we focused on people's task performance, and we tried to study real people doing realistic tasks. We focused on actual human outputs. But you might recall that roughly at that time, a new debate started, both kind of in mainstream media and in the research community, and people started pointing out that the deep learning AI systems now, being introduced into workplaces are changing workplaces and the experience of doing work, and it's not always for the better. So we took it to heart and asked ourselves, so what makes for a good workplace? And here we reached for the well-established self-determination theory. This is the theory that gave us the concepts of intrinsic and extrinsic motivation. And it also tells us that people in workplaces have three basic psychological needs that need to be satisfied in order for people to have good level of intrinsic motivation in the workplace. And these three needs are a sense of competence, a sense of autonomy, and a sense of meaning. So we reached for the sense of competence and decided to work with this first. And we asked whether people actually learn if they are assisted by an explainable AI. And we looked at this because there is quite a lot of literature demonstrating that in the workplace, people learn through incidental learning. So if I were to ask any of you to help me with a decision-making task, you would help me do a better job in the moment and solve the task. But I would also learn from this interaction. I would experience incidental learning, and I would do better in the future. So we asked, are people who are assisted by AI rather than a human being, are they also receiving the benefit of incidental learning? And therefore, is their competence and therefore their sense of competence increasing? So we designed a study in which people had to compare meals and answer simple questions like which meal has more protein or fat or carbohydrate or fiber. And in the baseline condition, people just responded to the question, received no feedback. In the regular explainable AI condition, the question would be posed and the meal assistant would say, I believe this is the right answer and here is the reason. And people would then make their decision. And we also had the cognitive forcing version where people would first make the initial choice. Then the meal assistant would say, I believe this is the answer, for the following reason, do you want to revise your decision? And people would have a chance to change their decision if they wanted to. And that would be that. So before I tell you the result, I have to quickly tell you what the baselines were. So one of the baselines was when people answered these questions with absolutely no support and no feedback. This is the leftmost bar. And here we see that some learning is occurring from instance to instance, simply because people do the same type of task several times. Our high baseline was people answering the questions and being given a feedback on their answers. And this was a high baseline. We knew from previous research that people learn from such feedback, and we did not expect anybody to do better than this. In simple explainable AI condition, we saw no evidence of learning. People did as poorly as if they received no feedback at all. And this we expected. To our surprise, however, there was also no evidence of learning in the cognitive forcing condition. So we asked ourselves, is there any other kind of redesign of the human-AI interaction for decision-making where we could elicit some cognitive engagement and therefore see evidence of incidental learning? And here we found some very interesting work from Kari Karahilios's group on how people navigate with navigation aids. And this inspired a solution where we just provided people with an explanation, identical explanation that they got previously, but no decision recommendation. So in this case, for example, the meal assistant tells the person beans are a significant source of carbohydrates. So it's a very easy cognitive step to go from this explanation to a correct decision, but still a person has to do this tiny bit of cognitive labor to get from what they're given to the answer. And apparently that was enough in this condition where people were given informative background information, but no direct decision recommendation. People performed as well as in other conditions on in terms of accuracy, but they also learned. They learned as much as if they had gotten expert feedback. But in this study, AI was always correct. So this was the best case scenario. So we wanted to do a follow-up in a more complex setting and ask, would this still work if the decisions were more complex and if the AI was occasionally wrong? So in this study, people were given a task of helping somebody figure out what types of exercises are best for them given their goals and given their health status. And in the explanation-only condition, people would get explanations like Pilates supports flexibility goals. And given that the person wanted to increase flexibility and lose weight, this is a fairly informative piece of information. So when the AI was correct, people would get a piece of information that pointed to the right answer. When AI was incorrect, in the explanation-only condition, people would get some true information. So running maximizes the intensity the person is capable of exerting, but this information would be misleading in the sense that this is not the most relevant piece of information for the task. So it would lead people toward incorrect answer. What we expected to find was that in the explanation-only condition, compared to the standard explainable AI where people are given both decision recommendation and explanation, that in the explanation-only condition, we again would see more learning and also that we would see less over-reliance because our mental picture of what was going on was that over-reliance was linked to lack of cognitive engagement. So if we force people to be more cognitively engaged with a task, obviously they will learn more and they will over-rely less. What we actually found was that indeed people did learn more in the explanation-only condition, but they also over-relied more. This was at first surprising, given that our mental model was that over-reliance and cognitive engagement lived on the same axis, that they were opposites. So it caused us to rethink our mental model of the underlying mechanisms. And we realized that with standard AI recommendation and explanation, people over-rely because they then not pushed to cognitively engage. But with the explanation-only condition, people cognitively engaged, but because they were given correct but misleading information, they over-relied because they engaged with this information so deeply. And it was very interesting that giving people just an explanation was more misleading, resulted in more over-reliance than giving people that explanation and also decision recommendation. So the challenge at this point was, can we find a design solution that would give us the increased cognitive engagement and learning without increasing over-reliance? And here we reached for yet another construct from social sciences, which is the idea of contrastive explanations. And some of you may have heard about it. There were a series of very influential papers from Tim Miller, and one of them specifically targeted the construct of contrastive explanations. So regular explanations that we often use in explainable AI give us all of the information that support a particular decision. Contrastive explanations, in turn, tell us you may think Q, you may think one thing, but the correct information is actually P. And I'm going to tell you all the reasons, all the relevant things, all of the relevant attributes in which Q and P differ, so that you understand why you should switch your belief from Q to P. And contrastive explanations are believed to be more effective for two reasons. First, because they kind of introduce a surprise. You thought Q, but I am telling you P. They appear more relevant, so people are more inclined to pay attention. And also because they only focus on differences between Q and P rather than all the relevant reasons, they're more compact and therefore easier to process. So the easiest way to implement contrastive explanations is to first ask a person, what do you believe? So this gives us the foil in case that they are incorrect. And then we tell them, actually, you think this, but the correct answer is something else. And here is the reason. However, our earlier work already told us that people do not like this design. This is something I didn't tell you earlier about cognitive forcing. People, over-relied less with cognitive forcing, but they really, really did not like it. So we're wondering, could we find a design for contrastive explanations that is as effective as knowing a person's true incorrect belief, but that would be more acceptable to people? So we wanted a design in which upfront we tell people, you might think resistance training, but it's actually Pilates, and here is the reason. But we suspected that it would really that this would only work if we're pretty correct about what the person's misconceptions might be. So how might we come up with the right misconceptions? We ended up building a second predictive model, one that predicted not the truth, but the likely human choices for a particular given task. So when we presented people with a task, we would present them with what AI believed was the most correct answer, but we would also present them with the most likely foil, most likely human misconception that was different from correct answer. So we ran an experiment in which one of the conditions was when we presented people with a contrastive explanation when the foil was predicted based on the model of human misconceptions. One condition was when people first presented their answer and then received an explanation based on their actual misconception, if they had one. We also had a baseline where the foil was chosen at random, just to see whether it really mattered whether the foil was plausible. And we also had a conventional explainable AI condition where people were given a regular decision recommendation and a full explanation. And of course, we had a no AI baseline. An important thing is that in terms of learning, people in the contrastive explanation condition where the foils were sensible learned the most, and this difference was significant with respect to all conditions, except for the contrastive explanations where people first presented their result and then received the recommendation. But even there, our system was no worse than the contrastive answer after. And in terms of over-reliance, there were no significant differences among the conditions. So and what I do not have over here, people did not dislike our design compared to any of the conditions, whereas they did dislike the condition where they first had to give a response and then AI critiqued it. So we did manage to find a design that improved human cognitive engagement and learning without increasing over-reliance compared to the standard AI recommendation and explanation. So this is one arc that I wanted to share with you. Here we responded to critiques that AI is ruining the workplace, and we specifically focused on the critiques related to human sense of competence and to critiques related to de-skilling of workers. Recently, and this is a different project, we were approached by Frontline Associates, which is an organization representing frontline humanitarian negotiators. So these are the people who will go to conflict zones like Ukraine, like Gaza, and they would negotiate with local authorities for humanitarian access to civilian populations. So they would try to negotiate food aid, medical aid, and all sorts of other support for the civilians being affected by the conflict. So they came to us and said, look, everybody is using AI. We must use AI, otherwise we'll fall behind. How should we use AI in our work? By that time, the ideas of self-determination theory were very much on our minds. So the colleagues who led this work, Wei Wei and Zilin, immediately thought competence, autonomy, and meaning. So they responded to the negotiators and asked, what is the meaning of being a frontline negotiator? What is the essence of your professional identity? So we conducted formative research with a couple dozen of frontline negotiators, and I think the most important findings were that effective negotiation relies on relationship building. We had some quotes of people saying, "Look, before I started talking about anything relevant, I spent several weeks just drinking tea with these people, so that we would establish just the minimum of human rapport. And only then we started talking about things that mattered." But they also say that they may have a bit of a plan when they go into a negotiation, but it very rarely goes the way they plan. They need to have a very solid understanding of the entire landscape of what might be possible, so that they can pivot on a moment's notice and respond to what's happening in the negotiation room, but also outside. Often the events happen very, very quickly, and outside events impact what's possible and what is not possible. So we wanted to develop a system that would support negotiators in making sense of the information that they need for their work, and in particular, knowing really well where they can build common ground with the counterparty, and giving them a good enough understanding of their options so that they can switch direction at a moment's notice. To get there, we studied how they currently prepare for their negotiations, and they have a number of strategies. So one is that they build an information artifact called Island of Agreements, where they list all the facts and all the norms relevant to negotiation, and they divide them into agreed and contested facts, or convergent and divergent norms. And the places where the parties agree, those are the island. This is the Island of Agreements. They also build another representation where they look at what is visible and try to infer the reasoning and motives of the counterparty, and also building bottom up for the party that they represent. And again, at all of these levels, they try to find what the two parties share in common. And also, they want to really identify and prioritize the issues to be discussed. And for each one, they want to establish bottom lines, which is where they do not really want to go below for both parties, and red lines where they absolutely cannot cross. So we've built a system that would take all of the information gathered for the negotiation, identify the Island of Agreements, identify the iceberg, bring out the issues, develop the red lines, bottom lines, and prepare kind of example scenario for each of them. The negotiators interacted both with standard ChatGPT and with the interface that we developed. They found that when they worked with regular LLMs, the systems would just give them suggestions for answers, and this totally wasn't what they needed. With our system, they felt that they were supported in their own thinking. And also, very interestingly, they weren't worried about the system's mistakes, because they say we are just so used to double checking absolutely everything that if there is a mistake, it's often a productive trigger for a conversation rather than the problem. But they were concerned that going into the future, that new negotiators who were supported by such systems might experience some level of de-skilling. Also, in more recent interactions with them, we found that even the system that we developed that is meant to prepare them, not tell them what to do, but prepare them for their own decisions, was still a little bit too proactive, and they would like to have a bit more control over how the information is gathered in the first place. So this is the second case study that I wanted to share with you. We have many more. Most recently, we've been working on trying to imagine what AI decision support for institutions might look like if what we wanted to optimize was the welfare of decision subjects, meaning the people about whom decisions are being made. So, for example, people applying for housing, people applying for land assistance, people or patients in hospitals. So, kind of my big takeaway is that being technologists, we are often, our first instinct may be to think about how our systems perform in terms of raw numbers. Um, but this is not the only objective that we might have. And as we expand our view of possible objectives to, for example, uh, consider human productivity, like Ben Schneiderman told us, or the quality of workplace experience for people who actually work with our tools, or the impact on people about whom decisions are being made, um, we encounter new problem definitions that open up room for new design adventures and often for entirely new technical challenges. And this is the end.
Okay. Thank you very much, Krzysztof, for this amazing talk. I think it's really very well aligned with what we're trying to focus on in the AHA program here at the Media Lab, basically supporting people in their own thinking, in their own decision making, rather than learning them or teaching them sort of to become dependent on AI for it. And I especially like how you're maximizing the meaning and autonomy and competence that people really desire in their work. Now, even you mentioned that these negotiators, for example, they really desire that autonomy. They want to understand things more deeply. But I'm curious, have you worked also with students, for example? Because maybe they don't understand yet that it's important, especially younger students, that it's important that they internalize knowledge and skills rather than just using the convenient route of delegating homework or thinking to AI. So, how do we convince an audience like that to really use these interfaces that are maybe a little bit more work because they force the kids to do some thinking for themselves rather than just presenting the answer to them?
Uh, um, No, I do not know, but obviously, as I'm an educator and I'm also a parent. My oldest is 9, so very, very soon I'll be thinking
Mhm.
about it incredibly hard. As an educator, what I strive to do is um, rethink my pedagogy and think very carefully, you know, in the current environment, what do I bring that students cannot get elsewhere? So I try to. So one thing that I try to do is change the what we aspire to. So
Mhm.
if AI can trivially bring us to this level, which was maybe perhaps the goal previously, I can
Mhm.
now raise the goal to here. So rather than telling students do not use AI to simulate user interviews, I can say if you do AI, you will get these stereotypical answers, which are not bad, but they're also not complete. These are not really useful insights. So use them to double check that you haven't forgotten anything obvious, but now try to get something even more valuable.
Mhm.
Um, so I think so. You know, during the first class in my design course, I always end up saying there's no such thing as user error. So we may be inclined to complain about our students making unwise choices, but then I have to remind myself there's no such thing as user error. So I think we're in a very interesting time where we have to ask ourselves, uh, how can we generate new challenges that are interesting and where the outcome of solving those challenges is actually really rewarding.
Mhm.
Keeps us on our toes.
Yeah. And it seems that there's a large role just for raising awareness and literacy training, and in the same way that we are being told, okay, you have to go to the gym and or get physical exercise someday, every day, or else you're going to regret it later on. It seems that increasingly we will have to tell young people, remember to practice your decision making, your thinking, practice the skills yourself, not just rely on AI, because you may pay a price down the road if when your skills have eroded, for example. Yeah. So we'd love to take questions from the audience. So again, we can take those in the Q&A or in the chat. You can type them in the chat. You can also just raise your hand and then we will unmute you so we can have you speak your question. So questions for Krzysztof. In the meantime, while we're waiting, I would like to ask, it seems that in a business context as well, that it's of course incredibly important that people develop their skills. And we've read, for example, that it's actually the most experienced people that actually benefit the most from AI support, because they may know when to trust the AI, when to not trust it, or when to believe it or not believe it, or how to interpret its results and use it in the best possible way. They know how to prompt it in the optimal way and so on. But of course, if we don't use our own skills or develop our own skills, we never get to that expert level where we can benefit the most from AI. So I'm curious to what extent you have had interest from companies and that are concerned about their talent pool and how to grow and develop their talent, basically, in their organization.
So we haven't had those conversations with companies. Interestingly, those conversations we've had with workers. So there's one company where we've had conversations for several years, and it's a software engineering organization. And the junior engineers would tell us, I'm very concerned about the development of my skills. So just like commercial airline pilots who occasionally say, I'm turning off the automation so that I can practice my landing, they say, for some tasks, I'll put AI away and I'll do it myself, just so that I'm confident that I still have the skills. Senior engineers, meanwhile, were saying that, of course, what they see as core of their professional responsibility is building systems that they can debug and modify as the need arises. So it's not just about building, but knowing it so well that you can jump in and fix them and change them. But also they were saying that another part of their core responsibility was mentoring new people. And they felt that AI was essentially co-mentoring new people, and they were concerned about junior engineers being occasionally misled by AI. So they felt that they not only had to teach and pass on their wisdom, but they also had to check on what people were actually getting out of the interactions with the AI and potentially jumping in and correcting.
Interesting. I thought actually that you were going to make another point when you talked about mentoring, and that you would say, well, we learn a lot from mentoring younger people and basically teaching skills and how we do our decision making and thinking to younger people, which may also be the case. But yeah, I think that point is interesting, that the senior people are frustrated by the bad habits maybe that younger talent are picking up from AI.
So they didn't say that they were necessarily annoyed, but they realized that it's another influence that they do not have direct control over, and that they felt responsible for making sure that they oversaw it.
Yes. Yeah. Interesting. We have a live question from Noah Jones. So,
Hi,
yeah, go
everyone.
ahead.
Yeah, great talk. And just to maybe introduce myself, I'm a PhD student in the effective computing group at MIT, and I'm in my final year where I work on mental health, my data sets, and using machine learning to improve our ability to detect different health outcomes. But my question is, oh, sorry.
Speak slowly because the audio isn't great.
Oh, okay, sorry. Let me see if I can update that. Okay, great. So the question kind of pertains to, I think, one of the findings where I believe you compared an AI system to human with AI and human alone. And in most of the cases at the beginning, a lot of the times the AI was performing above a certain accuracy level other um, compared to the other cases. And I was just wondering why that was, how the AI was trained, and kind of uh, essentially, I'm assuming that like surely there are some experts that can outperform this. And so I was just curious about sorry about the noise, but I was just curious about how that was yeah, how was that validated? If we could say more there.
So your question is, how exactly was AI performing at the level it was performing at? How we knew that?
Yeah, exactly. Yeah. Assuming that there are some experts that could probably outperform the system. I was just curious about why it was the case that the AI was outperforming human experts or human decision makers on many of these tasks.
Okay, so the first thing to say is that by the time we got to controlled studies, we typically replaced AI with simulated AI because we wanted to make sure that everyone had exactly the same or comparable experience. So we didn't want surprising behavior. This said, so in this study, for example, our experts were psychiatrists, specialized psychiatrists with gazillion years of experience. The people who participated in the study were primarily PCPs. Because what's needed, because PCPs often prescribe antidepressants, and it's very easy to prescribe the first one for easy cases, but it's actually really, really difficult to prescribe subsequent ones if the first one doesn't work. So could we help PCPs handle more complex cases? And one of the reasons why the system performs better than PCPs is because we had expert feedback, kind of input in preparing it. One of the reasons why it's not perfect is because it works with data from electronic health records, which do not contain all of the information about the patient, for example.
Okay, that makes sense. And sorry, you can say something?
Stop. Yeah.
Oh, yeah. Okay. So just to follow up, is because I think the contrastive explanations, they helped in improving learning outcomes for individuals. I'm just kind of generalizing across some of the studies, but in terms of the accuracy, are we is there kind of a way to kind of bring the accuracy back up to above AI? Have you seen kind of have you done some work basically in that area as well, where
Yeah.
you can bring okay.
Oh, interesting. Oh, okay. I'm disappearing
Yeah.
from the picture.
Okay.
So getting results to a point where people plus AI perform better than either people or AI alone, the word for it is complementarity. Everybody wants it.
Right.
I know that Patty had a paper once, at least once, where they reached complementarity. We occasionally get complementarity as well, but I don't think anybody has a reliable answer to it. So in this particular case, we improved learning without sacrificing over reliance, without sacrificing accuracy. We have not yet found a way to reliably improve both.
Okay, thank you so much. And I just want to say two things. I do think this is a really interesting talk, and I also agreed the major theme. I think I saw a quote saying you can't you can outsource your thinking, but you can't outsource your understanding. I think we need to use that
yeah.
motto more often.
But I'll just add here, kind of in the spirit of shared geekery, that some of the best results that we got in terms of accuracy when we cast the problem of choosing the right human AI interaction for decision making as a reinforcement learning problem. So for each interaction, we would choose a different interaction. For each instance, we would choose a different interaction based on our model of how much a person has learned about the task, about how difficult a particular case is, how confident the AI is, and whether the person is high in need for cognition, which is kind of an intrinsic motivation to think hard, or whether they're low in need for cognition. So based on all of these factors, the decisions would be made dynamically. And when we optimized for accuracy, or a combination of accuracy and learning, we got better results than any static policy. So
Cool.
adapting to a person's state and to task properties, is another way to improve the performance.
Thanks. And is that published? Is that published now? That paper that you mentioned for that study?
A working version of that paper is on our website, and it just got accepted to Tokai. So the definitive version will be available very soon.
Thank you.
Thank you, Noah. Let's go to a couple of other questions that we have. Edita Boguka, if I'm pronouncing that correctly, asking, and you seem to know each other, is asking, in a workplace context, what are your thoughts on using AI as mediators to capture and transfer tacit decision-making knowledge between junior and senior workers?
Oh. How very interesting. So I think it sounds attractive, but I think it's probably magic in most cases. So I am reminded of a very prominent strand of work from a while back, which was on design rationale capture. So the idea was that often, enterprises work on long-lived products like cars, rockets, or other things. And new teams look at a particular decision and say, why did they do it this way? And then make a change. And then they discover, aha, that's why they do it. Because if we don't do it that way, this indirect thing breaks. So often you want the rationale for decisions to be captured. And it turned out that it wasn't getting the right rationale to the right person that was the hardest thing. The hardest thing was getting things out of the brains of the designers. So I think the tacit knowledge, because it's tacit, it lives in people's brains. It rarely gets said. So once you have it, it's easy to deliver it to the right person, but creating the conditions in which that knowledge is externalized in such a way that it's not a major burden on the people having that knowledge, I think that is difficult. Maybe in situations now that AI becomes part of conversations, maybe we'll create new conditions for people to externalize some of their knowledge. But I think it will be, again, very difficult to do it in such a way that we do not put new burdens on people.
And we have a question from Fry in the chat. Fry is saying, in our post-truth era, hidden agendas become ever more important. Have you considered how decision systems can help participants identify hidden agendas of others, i.e., we're arguing about X, but that is just a diversion from the real import, a hidden agenda. As Patty mentioned, trust becomes paramount, which hidden agendas destroy.
So I think the last point made by the previous question asker, I forgot his name. Noah? Was it Noah?
Sorry, Noah Jones. Yeah.
Yeah. So Noah's last remark was, you can help with decision making, but not with understanding. You cannot automate understanding. And I think when I think about tools for decision makers, this is my ultimate goal. I want to make sure that I would love a world in which the tools that I build help people develop true and solid understanding that they can verify, and where the actual decision making belongs to them. So I actually understood the person's question a little bit differently, because hidden agendas can be put into the decision support systems, right? As we showed, giving people true but misleading facts is incredibly effective at steering people toward the wrong answer. We really want to make sure that we understand what aspects of the human AI interaction design are potentially misleading. We want to build systems such that they honestly help people develop deep understanding of their own, and make sure that we design workplace processes in such a way that people honestly make decisions on their own with great level of autonomy, and that they can feel accountable for those decisions. We do not want hidden agendas in our systems to steer how our public institutions work, for example.
We have a live question from Stephen Molotnikov, and I want to remind everybody we have a very hard deadline at 5 o'clock, so we will have to end there. So Stephen, maybe shorter question?
Sure. Hi, thank you so much for the talk. I have a question about this frame of cognitive forcing functions and contrastive explanations. I think it feels like it implicitly assumes that users actually should be engaging for their longer term well-being, but aren't because there's an easier path. And I was wondering why and when should a user use a system that will slow them down on the task they're doing in order to prioritize their long-term well-being?
Mm-hmm.
So again, I think learning is perhaps secondary to understanding in most cases. So when I think about these situations, I think of healthcare and I think about public institutions. I think that for especially non-routine tasks, we really want to make sure that whoever makes a decision understands it well, is accountable for it, and that requires that they have deep understanding of the task. And if you develop deep understanding, you also learn from the experience. So when people come to us and ask us, how should we introduce AI into our workplaces? We've now had several such conversations. The start of the conversation is, how can we do more and faster? But when we sit down with them, give them, a good cup of tea and say, take a breath and tell us what's really important to you and your colleagues, what's really essential to your profession. It's never doing more and faster. They all have outcomes such as, I want my patients to be really engaged in their own treatment. I want, families that I support to be happier and more robust. So I think all people who make non-trivial decisions are at some level committed to putting effort in what they do. And I think to some extent it is the fault of our community that we've been screaming, speed, accuracy, and efficiency so much that people are beginning to forget that other things matter to them. So I think engaging in the conversation when we ask people, what would a better world look like for your profession, we will discover that people are willing to put in the effort.
That makes a lot of sense. Thank you.
Patty, you're muted.
Unfortunately, we are out of time, but this was a wonderful conversation and a wonderful talk. Krzysztof, I hope people will check out all of the papers, and I also encourage people to check out a recording from the AHA symposium that we just held last week, where we talked about a world where the next generation is almost raised by AI, and asked the question of whether that's a good thing, first of all, and how we can encourage that that ultimately leads to that generation being better off. Thank you, everybody, for being here, and please come again. We have these talks every 2 weeks on Thursdays at 4 o'clock. Thank you, Krzysztof.
Thank you.